Hello everyone, welcome back to my general chemistry mini lecture. Today it's another important but also fundamental topic. It's the nomenclature of the chemicals. And before we talk about the naming, we can talk about the type of chemical bond. When you have a metal and a non-metal, metal like to lose electron and non-metal like to gain electron. So electron will transfer from metal to non-metal. Then metal will become a cationic ion, and that's called a cation. And non-metal will becomes anion, and they have opposite charge. So the attraction is called ionic bond. And in general, ionic bond is the attraction between cation and anion. It doesn't have to be monoatomic, can be polyatomic cation or anion. Now, when you have two nonmetals, they will like to share electrons, usually. And then when they share the electron, they can form a covalent bond. And that is by electron sharing. When you have metals, metals will form a metallic bond. The metallic bond is more like those cations of the metal. You can treat them as the island in the sea of electrons. So the electrons are delocalized. So that is called a metallic bond. Now let's talk about the molecules and compound. Molecules contain the same element or different type of element. And usually nonmetals form molecules. And compound must contain different type of elements. So that's the difference. I will use some examples to show the difference of these two different concepts. Now this is water. Water is a compound because there are two different elements, hydrogen and oxygen. It's also a molecule because both are non-metal. So general name is a molecular compound, or you can say covalent compound. Oxygen. This is oxygen molecule. It's an oxygen gas. It's not compound because just one type element, but it is a molecule because it's a non-metal, so it's a diatomic molecule. Hydrogen, if you see this symbol, then that's not compound, not molecule. It's just the atoms of hydrogen or the element symbol. This is a table sugar. It is a compound of carbon, hydrogen, and oxygen. And since they are all non-metals, so it is a molecule. So it is, again, molecular compound or covalent compound. Aluminum bromide, it is a compound because you have two different elements, but it's not molecule because it's ionic compound, not molecular compound. And because you have metal, non-metal here, or cation and anion. Last one is a sodium bicarbonate. It is a compound of four different elements, sodium, hydrogen, carbon, and oxygen. But it's not molecule because it's ionic compound. You have a cation and anion. Now, let's talk about more about the cation and anions in the ionic compound. Metals, such as sodium or calcium, they can only form one type of cation. They are so-called type 1 metal. And the name of those cation will be the same as the element's name. For example, sodium will always form 1 plus. So the name is just says sodium. Calcium always form 2 plus cation, and the name is the same as element's name, calcium. For other type of metal, like iron, they could form two different type of charge. So we call them type 2 metal. So then for this type 2 metal form the cation, we need to use Roman numeral to indicate the charge, the positive charge. So this is iron 2 in parentheses. This is iron 3, the 3 in parentheses. This is Roman numeral. Another example of type 2 metal is copper. Copper could form 1 plus and 2 plus, two different type of charge. So you need to use Roman numeral in the parentheses show the charge. This is copper 1, this is copper 2. There's a very common polyatomic cation. Those are monoatomic cation. So common polyatomic cation is ammonium. It's NH4+. So don't be confused. We treat this as type 1 metal, okay? Because always +1 charge. But if you look at the element here, there's no metal. So it's confusing, but we treat this as type 1 metal. Okay, it's called ammonium. Now let's talk about the anions. Anions can be formed from the nonmetals, just like a monoatomic anion, like chlorine. The name of the element is chlorine, but if this form the anion, you have to change the name to ide. First syllable plus IDE, chloride. It's -1 charge, always form -1 charge. Oxygen will always form 2 negative charge, and that's called oxide. Follow the same rule, first syllable plus IDE, oxide. Nitrogen, when they form the monoatomic anion, will be 3 negative charge. So the charge formed is based on the octet rule. Okay, so name will change to nitride. Hydrogen, if they form the anion, when they receive 1 more electron, that's called hydride. Follow the same rule. Now, that's all monoatomic anion. There are also polyatomic anion. I'll give you some examples. Nitrate. This is NO3 minus nitrate. The charge will not change. Okay, those charge will not change. Sulfate, carbonate. Okay, that's -1, 2 negative, 2 negative. Now let's look at the examples of naming of ionic compound. Keep that in mind. Okay, type 1, type 2 metal have cation have different rule. Sodium is type 1 metal. The cation is called sodium. Anion is chloride. The name is sodium chloride. That's a sodium chloride. Since this type 1 metal, so you do not need to use Roman numeral. So it's table salt. We know that. Now this is iron 3 oxide. So cation is this iron 3 plus. That's the cation. Iron is type 2 metal. Okay. Oxide is 2 negative charged. So if you don't know the charge of this type 2 metal, especially if you just see the formula, you need to figure it out. You need to calculate the charge based on the charge of anion. Oxide is 2 negative. You have 3 oxide. So total negative charge is 2 times 3 is -6. So the total positive charge should be +6. +6 divided by 2 because +6 is shared by 2 ions. So each ion should be 3 plus. Okay, there's a little calculation here. So because this is a neutral compound, the positive charge and negative charge should be balanced. Now the name is iron 3 oxide because this is type 2 metal and the charge is 3 plus. So you have to use the Roman numeral here. Iron 3 oxide. It is iron rust. Now this is baking soda. We just talked about this. The cation is sodium, anion is bicarbonate, or you can say hydrogen carbonate. And the name will be sodium bicarbonate. It is baking soda. Okay, so sodium again is type 1 metal. Copper here is type 2 metal. Copper sulfate. The cation is copper 2 plus. Sulfate is 2 minus. So again, this charge is based on this charge because it's 1 to 1. So you have 2 negative. The copper must be 2 plus. And so name is copper 2 sulfate, type 2 metal. This is a type of aldehyde. This is ammonium phosphate. Cation is ammonium. Anion is phosphate. So you see phosphate is 3 negative. Ammonium is a +1, 1 plus. So you need 3 ammonium to balance the charge of 1 phosphate. That's a 3 negative. So you should have 3 positive now. The name is ammonium phosphate. It is a fertilizer. This is another example. This is barium nitrate. Barium 2 plus. Barium is always form 2 plus cation, and nitrate is -1. So the name is barium nitrate. It's type 1 metal. This is the palladium acetate. Palladium is actually type 2 metal. So you figure out the charge by the charge of acetate. You have 2 acetate, so you have overall 2 negative charge. This palladium should be 2 plus, so the name will be palladium 2 acetate. Okay, this is an example of the ionic compound. Now let's look at the molecular compound. So we know the molecular compound always have nonmetals. See, that's all nonmetals: carbon, oxygen, nitrogen, hydrogen, phosphorus, and sulfur, fluorine. So to name the molecular compound, we need to know the prefix because we do need to say the subscript. Okay, for ionic compound we don't need to do that, but for molecular compound we do need mention the subscript. So this is prefix. Okay, so mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Other rule is if there's only one atom of the first element, you do not say mono. So second, if the 2 vowels like O and O or A and O appear together, the first vowel will be omitted. Now look at the example. This is the carbon monoxide. Don't say monocarbon monoxide because the first rule. Okay, this is carbon dioxide. Don't say monocarbon dioxide. Okay, carbon dioxide. Also go back to here, carbon monoxide. See, supposedly it's a monooxide, but based on the rule of 2, so the 2O will omit first O, so monoxide, not monooxide. This is laughing gas. This is dinitrogen monoxide. Again, same thing here. So not monooxide, it's a monoxide. This is water, dihydrogen monoxide. This is tetraphosphorus trisulfide. This is sulfur hexafluoride. So follow the rule, should be easier than the ionic compound. Now, what's the difference between the ionic compound and the molecular compound? When they dissolve in water, you can see the difference. The structure of the ionic compound is the cation and anion, cation, anion, attracted by our ionic bond. So when you dissolve those ionic compound crystal in water, the ions, cation, anions will dissociate, will separate in water. So when you dissolve that in water, they actually separate to cations and anions. So they will not have the formula cation anion together anymore. So they will separate to ions. So this solution will be a conductors. For the molecular compound, when you look at the structure of molecular compound, I use this cyclo, the hexagon show the individual molecules. So there are 2 types of attraction. One is called intramolecular attraction, that is covalent bond, and they also have those attraction among those molecules. Those are called intermolecular attraction. Intermolecular attraction are much weaker than intramolecular attraction. So when they dissolve in water, just break those intermolecular attraction. So you still see those molecules. Okay, you still have the covalent bond as an intramolecular attraction. So that's the difference. Okay, now let's talk about acid and base. Based on the Bronsted-Lowry definition, acid is a proton donor. Base is proton acceptor. What is proton? So that's based on the structure of a hydrogen. Hydrogen atom has 1 proton. Actually, I should say most abundant hydrogen isotope has 1 proton in the nucleus, no neutron, and 1 electron outside. So when they lose 1 electron, this hydrogen atom will lose all electrons. So that will be just proton left. So that's why H plus is called a proton. Okay, let's look at the common acid base name. There are rules for acid of if it's a binary, like just the 2 element, hydrogen, chlorine, hydrogen, sulfur, you have to say hydro, and then change the second nonmetal to the first syllable plus ic acid. So this is hydrochloric acid, hydrosulfuric acid. That's the rule. If it's just a binary, you have this hydro, say hydro. If it's the ternary, so that means more than 2 elements here. And also this is so-called oxy acid. So you have this. The name will be based on the polyatomic anion. You can see NO3 minus is nitrate. If it's 8, change to ic acid, so nitric acid. Do not say hydro, okay, nitric acid. This is another acid with this nitrite as a polyatomic anion, NO2 minus. So change the I to us acid, that's a rule. So nitrous acid. This is H2SO4. This is SO4 2 minus is sulfate, change the A to ic acid, so sulfuric acid. A little bit different, right? So, and now this is the chlorate. Chlorate is the polyatomic anion here, so change this to chloric acid. This is a hypochlorite polyatomic anion, and we change this ite to us, so hypochlorous acid is the name of this acid. So based on the polyatomic anions. Now base will be a little bit easier. So here list the 5 strong base and 2 weak base here. This is sodium hydroxide, and this is potassium hydroxide. This is cesium hydroxide, barium hydroxide, and the calcium hydroxide. See, because they are all type 1 metal, so you don't have to use Roman's numeral. Okay, and this is ammonia, is a weak base, and this is methylamine, that's an organic base. It's also weak base. So that is all about nomenclature, and if you have any questions when you start it, please let me know. Okay, I will be happy to answer your question. Good luck.